welcome back to the channel. Another lecture. We have another theorem to prove, and let's get into it. So we have to prove that for any minimum spanning tree T of G, any cut S and V minus S cut, and for any minimum weight edge E crossing the two cuts, if E is not part of T, then any edge in T crossing this cut must have the same weight as edge. Okay. Let's prove this by contradiction. Let's prove this by contradiction. So it's saying if E is not part of T, then any edge in T crossing the S must have the same weight. Okay. The cut property says it must have same weight or less than. Okay. Let's say there's an edge T is a minimum spanning tree of G, and it has a cut, and it has a edge crossing S, V minus at S cuts, whose weight is greater than the other edge crossing these cuts. Okay. Now let's remove this edge such that weight of this edge is less than weight of edge E. Okay. So let's paste edge E in another T bar such that T bar is a spanning tree because it still connects all the vertices. Okay, so we know that weight of is greater than weight of E bar, so we can say weight of T is greater than weight of T bar, which contradicts because edge E is in T and edge E bar is in T bar, which contradicts the fact that T is a minimum spanning tree. Okay, so T can be a minimum spanning tree then, and our statement in the beginning. Let's prove this by contradiction. T is a minimum spanning tree of G, and it has a edge crossing S whose weight is greater than the other edge E crossing that. Let's say the weight, that's what we said. But our main statement was this: if E is not part of T, then any edge in T crossing the S we cut must have the same weight as. Okay. We just said, let's say it doesn't have the same weight. Okay. So that's it. This is proofs.